Hello everyone. So there was an issue on the login portal. Okay, so I just end that string, but from this we'll continue with the Gauss elimination topic. Okay, so I was trying, and even for nearly 3 to 4 minutes, but it didn't work. So I said to uh, re-stream it. Okay. So in that lecture, actually not that lecture, but the part of today's lecture, we discussed about diagonal trigonal matrix, and today now we will be discussing about the Gauss elimination technique. So let me share my screen. Fine. Okay. So let's begin. Introduction to the system of linear equations. So if you have studied that basic lecture course, you did that course, then you know the basics of this system of linear equation. We discussed the more sophisticated, one of the most sophisticated method, that is Cramer's rule, okay, to solve the system of linear equation, and even the matrix method also. So I'll not discuss that particular, okay, but just in brief revision. So suppose we are with this particular expression here, just taking this particular example. So these variables are called unknowns, okay, and this is a system of linear equation, also called as linear system. It look like this. Here we discuss the matrix method, that is Ax is equals to b, and then comes your consistency and inconsistency. If it has one or more solution, then it is called consistent, and if it don't have any, you can say it doesn't have any solution, then it's called inconsistent system. Okay, and now we will be discussing about the linear system in 2 and 3 unknowns. So that is you're making the line, a concept of line only, and then the plane also. So linear system in two unknowns arise in connection with the intersection of lines. So actually this is the geometrical interpretation of linear system, you can say linear system of equations, system of linear equations. That is, if we are discussing the two unknown system, then we are just discussing the point at which uh, two lines intersect, okay, and that particular point of intersection is the solution. Okay, and line may be parallel distinct. In that case there will be no intersection and no solution will be there. If it is intersecting at one point, then we'll have a unique solution, that is called exactly one solution. And if those lines which we are drawing, two lines, they coincide, then they are called as infinitely, they show infinitely many solutions. Okay, and then comes your case of three equations. So in three equation we discuss mainly about planes, as it is given an equation of planes, and the 3 points, the 3 planes where it is intersecting, that is giving you the unique solution. Okay, and again we see there are only 3 possibility: no solution, one solution, or infinitely many solution. Okay, so every system of linear equation has 0, 1, or infinitely many solution. Means any system of linear equation you are taking, it may have zero solution, it may have one solution, or it may have very much, you can say infinitely many solutions. There are no other possibility. Now this is the basic, using the 6th 7th class mathematics algebra you can solve this. So I'll not take this in our today's discussion. Okay, these are the same problems. Because this, like these you can say PDFs are made so that anyone can read if you don't know even the basics. I'll not give that much, okay, liberty in my class. Now we'll discuss about non-homogeneous system. As you know, non-homogeneous system means these b1, b2, bn all are non-zero. Okay, if they are zero, then they are that is homogeneous system, as we discussed, okay, already. Now here, this is a very important thing, that is the introduction to this Gaussian elimination technique. So the matrix, this looking like this, actually not like this, but more specifically we will show in this way: A and this bar B, and this will be called as, while placing the column B to the right of A, it's called augmented matrix. It's called augmented matrix, like this. Here we can use a partition also. So this will be the elements of this A, and there we will have elements of B. So the algebraic operation to perform this, that is performed to solve this system, are the elementary row operation, which has been explained here. Okay, we'll take some examples also. These are the elementary row operation, as we discussed. Now very important is the row reduced echelon form. So once we have a row reduced echelon form, then we can even guess, we can give a surety that whether the system has a unique solution or it has a no solution or the infinitely many solutions, so that we can bet if we have the knowledge of row reduced echelon form. So by a sequence of elementary row operation, the augmented matrix can be transferred to a matrix which have the following properties. If a row does not consist entirely of 0, then the first non-zero number in this row will be called as 1, and we'll call it as leading one. Actually, we are discussing this leading one, that if suppose we have a row, okay, and here we have some element which is non-zero, and here all elements are 0. So this particular element is called leading one or pivot. These are called pivot element. Again, if there are any rows that consist entirely of 0, then they are grouped together at the bottom of the matrix. Okay, then we can use the elementary row operation and we can just group it to a bottom of matrix. We will take example to understand this. In any two successive row that do not consist entirely of 0, the leading one in the lower row farther to the right than the leading one in the higher row. Okay, we'll discuss about this. Okay, and let's take an example again, because maybe or even certainly this will be a little difficult. Okay, so just how to reduce this I'm discussing with you. Okay, don't worry. So you have to use the elementary row transformation. How you can use? Just taking this second one, you have to make one row or one column constant. Mainly we are discussing row reduced echelon, so we'll consider row. So we'll make this first row constant. Okay, or you can say we will operate it in a different way, like I'm discussing with you. So suppose we are taking this R2 and we are performing the operation here, that R2 undergoes R2 minus 3 times R1. Okay, so suppose we have this R1, this is constant, and we are just using this 0, 1 minus, you can say 3 times I'm doing 1 minus 6 minus 5. Okay, this is R1. Okay, you are not clear, then R1. Okay, fine. Now minus 2 and minus 3 minus 5. Okay, it's fine, I think. Okay, 1 minus 6 minus 5 and minus 2 minus 3 minus 5. Now just operating this R3. So R3 undergoes R3 minus 4R1. What will be getting? 0 and minus 8. Okay, minus 11. Fine. Minus 1 minus 4 minus 5. Again, wait. Fine. R4 undergoes R4 minus 2 times R1. Zero. 4 minus 4, again 0. Okay, 2 minus 2, again 0. This is actually 2 times of this row. Right? Yeah. Now what we can do? Now we can do some more, I think, manipulation here. Okay, so the operations are quite the same which we have used to get this particular, and now you can use this particular expression again, which you can understand from here. This is the sign which we use to you can say denote an augmented matrix. So which we have already discussed, and now R2 undergoes minus 1 by 5 times R2. So this will be 0 again. This will be 1 now. This will be again 1, and these two will remain same. Now again R3 undergoes R3 plus 11 times R2. So when you will do the same, you will get here 0 in the third row. Here you will be getting 11 minus 5, that will be 6 here. And now you can use the final operation, I think, that is R3 is equals to 1 by 6 times R3. So that will be your again 1 here. So like this you can reduce, and this will be the row reduced echelon form. And here from here you can also discuss some of the things that this element particularly, okay, this element and this element, these three are called as pivot element, because the element, because this element, if you will notice, then the bottom of it and left of it, here there is no left, but bottom to it is all the zero elements. So pivot is in, this is called pivot element only. It's pivot element, or you can say leading element, pivot element. And this pivot is a non-zero element, and this is actually the deciding for the you can say consistency of the system. So here you can see that here we have pivot, here we have pivot, here we have, and this is row reduced echelon form, which you can check by a staircase. It is like a staircase, so it is a row reduced echelon form. And now Gauss elimination technique or method to solve the system of linear equation that we'll be discussing now. Okay, that will be our today's goal only to discuss. And even the homogeneous system of linear equation also we'll discuss. Fine. So just first example we'll be discussing first by Gauss elimination technique. Okay. So as you know, by the matrix method, you can say that this A will be the coefficient matrix, B will be this 2, 1, 3, 4, the matrix forming by this. And now writing the augmented matrix. So you can write this augment by combining A and B, like using this. Now you have to reduce this in echelon, row reduced echelon form, as I discussed with you. And from here, you can check the consistency, as I discussed with you, by using the pivot element. So this is one pivot element, this is one pivot element, this is one pivot element. So you have three pivot elements. You have three pivots element, and you have three unknowns. And even the rightmost column, if you can check, there is no pivot. In the rightmost column, this you can make a partition also here, and that the rightmost column doesn't have any pivot. So actually, you have three unknowns here, x, y, z, and you have three unknowns or four unknowns. Let me check. Three unknowns, x, y, z. So you have three unknowns and three pivots. So whenever there is one, you can say Brahmastra of this Gauss elimination technique that I am writing, R. R will be number of pivots. Okay, and this R, if it is equal to n, n means number of unknowns, and provided that rightmost column, which I am writing R and C, has no pivot, no pivot, then we will say that it has unique solution. Unique solutions. Okay. So if R is equals to n and rightmost column has no pivot, then we can say it is a unique solution. This is the same case of unique solution, and which you can solve also by just using this particular, or you can use the your traditional method also. Here you have five unknowns, so you will check the row reduced echelon form. So you can find this augmented matrix as I discussed with you by just combining A and B, and then you can reduce it to row reduced echelon form, which is a little, not little, very much lengthy here. And from here you can get this row reduced echelon form. So this is your first pivot element, this is your second pivot element, and you have wait, yeah, two pivot elements are only there. You can check also. No, no, no. Okay, you have only two pivot elements. So here you have two pivot elements, and the unknowns are five, I think. Yeah? Five unknowns are there, and two pivots elements are there. So whenever, and the rightmost column you are computing here, the rightmost column, then what you will getting? Check here. Rightmost column does not have any pivot element as such. It doesn't have any pivot element. You can check here. It is not a pivot element. So then this is a case of infinitely many solution. You have two pivots. R is 2, number of pivots is 2. Unknowns are 5. So what's the difference between them? That will be called as free variables. N minus R will be a number of free variables. FB I'm writing free variables, and that free variables will be, you can choose that as in whatever value you want. So here you have also, we have chosen here RNS, and we got this. Okay, three pivot. Let me recheck. Not really three pivots. Okay, I'm not getting three pivots here. Two pivots only. Then you have three free variables. Let me check. Okay. We are assigning x2 and x4. According to them, these two are the, and this is the pivot element. Pivot row. Yeah, here. I missed. So this is one pivot element because the left to it and the bottom to it is 0. So we'll have 2 plus 1. Okay. And here n minus r is number of free variables, and that will be here 2. And that we have assigned RNS. Fine. Again, Gauss-Jordan elimination technique, you can use the same method. There are several examples given. I will not discuss all of them. Okay. So these are the similar examples. So you can check also. Homogeneous system of equations. The system of linear equation is said to be homogeneous if the constant terms are all 0. This part becomes 0. Okay, that is called the, and here comes the concept of trivial and non-trivial. So if I am just taking the x1 up to xn as 0 0 0, that is trivial solution. That is not such useful. But for non-trivial solution, we will consider the, here we'll have no case where we'll be getting no solution, because 0 comma 0 comma 0 will be the surely the solution. So for non-trivial solution, you can use the concept of the same which we have discussed. That will be, it has an infinitely many solution, and the free variables theorem for homogeneous system also, that we discussed is n minus r. Okay, we discussed already this. And from here, okay, you can check the augmented matrix again. Row reduced echelon form you can make, and you can find the same. So the same process goes for this. Okay, no such, I would say, advancement. Okay, so this we have discussed that it has 0 1 or infinitely many, so there are no other possibilities, already discussed. Again, if A is an invertible matrix, then for each n cross 1, if A is an n cross n, then each n cross 1 matrix B, the system Ax equal to B has exactly one solution, meaning x is equal to inverse B. Fine. This is an equivalent statement, that if A is n cross n, the following statement are equivalent. A is invertible, Ax is equal to 0 as only one trivial solution. The reduced row echelon form is In. That's simple interpretation. A is expressed as a product of elementary matrix that we discussed on this. Okay. There it is also given the proofs that will not taken special attention over. Okay. This is the way we discussed augmented matrix. Okay. This we have already discussed. Okay. These are again the problem which we discussed already. Invertibility and all. Trivial, non-trivial, this we discussed. Augmented also we discussed. Here it also matrix transformation. Okay. This is not actually in our today's lecture context. Okay. So this will be discussing in the next lecture. Okay, transformation and all, linear transformation and all. That will be discussing in the next lecture. This was our today's lecture context. Okay, which we discussed. Okay. Fine. So yes, so this was our today's lecture on Gauss elimination technique. In next lecture, we'll be discussing more on linear algebra. Thank you so much for joining me in this session. Please do like, share, and subscribe to my channel. Thank you so much. Bye bye. Take care. And please do revise all these topics. Okay. Thank you. I'm ending this stream.